Good day, everyone, and welcome. My name is Kayla Altman, and I am a Communities Coordinator at ASUG, and I am pleased to welcome you to today's webcast, Operationalizing Internet of Things, Data for Predictive Analytics, Episode 5 of 8 of an ongoing series, and thank you for your participation today. I do have a few housekeeping notes as well as a few announcements for you before we officially begin. The first is a reminder that you can continue to participate in webcasts such as this one by looking for your personalized webcast listing each Monday. You can also visit us at asug.com for additional webcast information. Today's webcast will be recorded, and the recording along with the slide deck will be posted to the ASUG discussion forum within the next couple days. We will also email these materials out directly to you by close of business today. If you have a question throughout the webcast, we encourage you to please submit it using the Q&A panel, which is located on the side of your monitor. We will go ahead and moderate those questions at the conclusion of today's presentation. A reminder for anyone interested in SAP Analytics or Business Objects that we have a fantastic conference coming up in Austin, August 31st through September 2nd. You are encouraged to join us for 3 days of networking and education at what's sure to be a fantastic event. Co-located with that event is the ASUG Business One Summit. So if you or anyone you know has an interest in Business One, we do encourage you to visit us on asug.com for more information on how to participate in that. Another strategic initiative in addition to Internet of Things includes a focus on human resources. So on asug.com, you can connect with our newly formed HR community, where you can participate in webcast content as well as up-and-coming influence sessions. It is now with great pleasure that I turn us over to Paul Kruchina, who is our community advocate for Internet of Things, and he will introduce our speaker for today. Paul?
Thank you very much, Kayla, and welcome everyone to episode 5 of our 8-part series. And just as a reminder, as you can see on the screen is actually a link, a listing of all our webcasts, as well as a link to where to go to sign up for webcasts in the series. We are recording all these webcasts, so all the recordings and presentations will be posted, and you can take a look at them at asug.com/IoT-webcast series. In addition to that, I also want to highlight if you're interested in joining the ASUG IoT community, all you have to do is send an email to iot@asug.com. That's iot@asug.com. You'll get some information, not just on how to connect to the community. Of course, you'll get information on these webcasts, how to view the recording, but you'll also get other information on SAP IoT sources of information from an SAP context that I think you'll find quite interesting. And the other thing I would like to request of our attendees at the end of this call, we'll put up some polling questions for you to share your perspectives on what was one key thing you got out of today's webcast, as well as what is some other information you would like to hear about in future webcasts or some things that you would like to understand better. In some of our previous webcasts, actually, I'll go on the next slide, Kayla, sorry, before doing the intro to Dave. One of the things I want to sort of highlight is upcoming in Chicago the week of from June 23rd to 26th is the SAP Manufacturing Industry Forum. There will be quite a bit of IoT content that will be at that event. There's an IoT workshop the afternoon of the 23rd, as well as some key content. So you're in any one of the target industries listed on the slide, and in the Chicago area as a customer, I would definitely encourage you to attend. Now, one thing I want to say before introducing today's speaker, it's interesting that I think it was webcast 2 or webcast 3 of this series. There are a few comments made by one of the SAP speakers that really talked about the fact that these two worlds of IT, information technology, and OT, operational technology, are starting to combine. And to take that further from an OT context, an IoT context, to really understand IoT, you also need to understand operational technology. To help put that into perspective, I've invited Dave Roberts from OSIsoft and Frank Ruland from SAP to speak. And from my perspective, no one better than OSIsoft, given their deep knowledge over the years in the operational technology space, to share with you their perspectives in this area. So Dave, I'll turn it over to you.
Thank you, Paul. Thank you, Kayla. Hello, everyone. My name is Dave Roberts. I'm with OSIsoft. I've been with the company now 10 years. I've played a number of roles in the company in various senior leadership roles. Most recently, the last couple of years, I've been working in smart and connected cities. I've been working on our IoT and relationships and technologies that are really, I think, paradigm shifting in terms of how we get data, how we analyze things, and how we integrate with high-end systems like SAP. My talk today is really broken down into a few components. First is a quick review of OSIsoft and the PI system, just to level set everybody. And then I want to share some observations and anecdotes of what I've experienced, what our company's experienced in the IoT space. And then we want to, of course, spend some time talking about how the PI system and SAP HANA integrate together and look at that integration where we bring that OT to the IT world. And then we'll pull that together with a demo at the end with a customer use case to really show some of the capabilities of the two systems operating together, and hopefully leave 10 to 15 minutes on the back end for questions, answers, little discourse, etc. So with that, we'll go ahead and get started. And feel free to type your questions through the chat window. Paul and Kayla will be assembling those questions, so feel free to write them down as we're going through the slides, and then we can address them towards the end. So just a little bit about OSIsoft. The OSIsoft, the company's been around for 35 years now. It was founded in 1980. We have about 1,200 employees, of which I believe better than 1,100 are engineers, typically with advanced degrees. And we make one thing called the PI system. And we're spread out all over the world. And that PI system has been used for many, many years in heavy process industries, manufacturing industries, and utilities. And I'll go through what some of those functions are. Some of our customers, you'll find PI systems in heavy process industries, as I mentioned, oil and gas, particularly, something like 55% of the refineries and high percentage of the gas pipelines and LNG stations and things around the world, all using the PI system. In metals and mining, if you go to the Rio Tintos and the BHPs and the Freeport-McMorans and the Barricks of the world, they're using PI systems for getting this operational granular sensor and process data. If you look across process industries, whether that's chemical, specialty chemical, pulp and paper, bio, pharma, etc., those are also have large install bases of PI systems. Again, tending to be on the manufacturing layer in that operational environment. And then in energy and utilities, here in the U.S. we have, and worldwide, we have a very high installation in power generation, distribution utility, all of the transmission system operators, the majority of the nuclear fleet, et cetera, all running the PI system. In total, we have 14,000 or so deployed systems and customers out there, and that's direct sales. In addition, we supply our technology to many of the industrial automation vendors, and they use the PI system for a wide variety of uses. So Rockwell's factory automation suite has PI in it. Kongsberg, who does control systems for ships and LNG and cargo ships and things has pi in it. Schneider Telvent SCADA system has pi in it. Emerson, GE, the Frame 7 gas turbines that go out all have pi systems in it. So in addition to those end users using pi, you're going to find pi systems used heavily by industrial automation vendors worldwide in a whole bunch of different use cases in this operational technology space. We like to say that we've been doing IoT for better than 30 years. When Pat Kennedy founded the company, his job and what he founded the company on was the idea of going into a refinery and going in and acquiring all the sensor data from all the different systems and control systems and things in that refinery and bringing that data together so he could do his consulting job, which was really doing some consulting analytics around how the process of the refinery ran. And he figured out that it took almost all of his time to go around and get all the data together and get it into a format that he could use to then do his analysis and present the solution to the refinery operator. I believe at that point is when he had the aha moment to switch the business model from trying to sell consulting hours to creating a product that would allow you to aggregate all this rich sensor and asset data from around a manufacturing facility and bring that together into one place so you could do your analytics. That was 1980, 81, 82. I personally, 1980, was still in junior high school. So we've been at this a long time. And so I want to talk a little bit now about what is this thing called a pi system, if you're not familiar with it. And then we'll get into the detail of operationalizing the IoT. The pi system really comes in three layers. The first layer is the idea of data collection. So if you think of SCADA and that data collection function, we have, I want to say, on the neighborhood of 480 plus or minus interfaces now in our library that go in and connect to these low-level systems. So if it's a DCS or a SCADA or a building management system or a manufacturing execution system, all of those types of systems that are out there in this world all produce data. And we write native interfaces directly to those systems to acquire all that data.
So,
now,
so you're collecting data off those sensors, correct? The sensors in the field.
Correct. Yep. So we go to sensor, we go to PLC, we go to control system, we get it all. And our library is right now is about 480 of these interfaces and connectors. And I think we spend on the average, I think we have about 50 plus or minus engineers and product managers who spend all of their time focused on this idea of interfaces and connectors. Right? How do we get the data in? And so that's part of our value prop is looking at all these heterogeneous data sources and flowing that into the system. Then that data has to go somewhere, and that middle piece is the Pi server itself. And the Pi server at its core is a time series database, and it's quite capable and quite large in terms of its scalability and width, and I'll get into a little bit of some sizing and some metrics on that. And then the third piece, which is really part of what we're going to talk about today, is then we present that data directly to users, but we also present data into analytics for a wide variety of use cases. And what we're going to touch on today is that integrator layer, the Pi integrator for SAP HANA, and how we present this rich time series and contextual data from this operational world up into HANA for analytics and the convergence point between IT and OT. So just touching base on this again, the idea of connectivity. The Pi system does that connection directly to those sources of data. How that's evolving for us is historically we've deployed these interfaces and connectors on x86, Windows, industrial PC types of platforms. So if you wanted to get data from your building, for example, you go deploy a Windows PC, industrial PC in that building, and you might put a BACnet interface on there and talk to the local building management system. With this idea of IoT, what we're seeing coming into the marketplace is smart technologies from primarily, these big silicon vendors and connectivity vendors. And so we're working with each of them to look at our connector product and strategy and interfacing and how do we put that onto some of these more distributed technologies. So Qualcomm, for example, they have something called a Dragon Board 410C, which is a Raspberry Pi-like thing or Arduino-like thing on steroids. It has a whole bunch of compute capacity and it has a bunch of connectivity, and they're very low cost. And we've been testing putting our connector framework and connectors directly on these little boards. And these boards can be attached to sensors, or they can be attached to assets like vehicles. They can do a lot of different things. Cisco is putting a lot of capability into their router technology with their IOX platform, which means I can put my connector framework directly on the Cisco router. And we demonstrated at our user conference a few months ago, in the utility use case, we deployed a DNP3 connector on the Cisco IoT or on the Cisco router. And that DNP3 use case is really about connecting to your utility infrastructure, not only at the substation, but thinking about distributed electric vehicle charging infrastructure and energy storage and distributed energy resources, and ideas of taking these routers and mounting them on utility poles and being able to, in a very wide context, be able to acquire data from that infrastructure. And then Intel, of course, we're working with them and their ODMs. They work pretty heavily with Dell and others who are creating gateway boxes that are intended to be low cost, easy to maintain, easy to provision and deploy gateways that we can put our connector technology on. Now, adding complexity to that, all of those technologies are also supporting a wide variety of standards that seem to be emerging in this IoT space. Talk about all join, we see Thread, we see IEEE, we see the Open Internet Consortium, OIC, and the IIC all promoting different standards about how these sensors and assets will communicate with these gateways and routers. And so part of the research and R&D and development that OSIsoft is doing and pathfinding we're doing is trying to figure out, if you're working, let's say, in all join and you want to create and build sensors using all join that broadcast their sensor data, how do you get that data via the gateway and on up to the PI system? And most importantly, you want the time series data about the sensor and the temperature value, for example. But you also need the metadata or the context around that sensor. Where is it located? When was it installed? What's its serial number? How is it, calibrated? All of that metadata is very important as you start to move up the stack and start to run your analytics against that sensor, right? And if you're going to trigger actions based on that sensor data, you need to understand all of that. So all of that data needs to go somewhere. That's the role of the Pi server itself. A typical common Pi server running on a 1U type of server application, we do systems that are on the order of 20 million writes per day. We can handle that single system can handle about 1 million events per second coming in from the infrastructure, and we can handle about 10 million events per second out, and then probably a total of about 20 million tags on a single server. Putting that into context, some of these big data clusters, high performance clusters that you see out there for running analytics, they have 100+ machines, or virtual machines spun up, and they're managing something like 9 billion writes per day. So if you look at that little dot, a single Pi server relative to one of those clusters, we look pretty small. But we can start to cluster these Pi systems together into high-performance Pi environments, and we're seeing systems coming together where we're looking at, orders of magnitude, billions of writes per day into those Pi systems. Some of those large systems are things like utility ISO systems. We have big electricity grids with lots of data flowing into them. So we're talking about how do you manage, huge volumes of data. And as we see this explosion and proliferation of sensors and gateways and people talking about millions and billions of connected devices and things, we think the scalability question in how you're going to deal with that time series data and the contextual data around all of those things is going to really start to flex that technology. So in summary, the Pi system, this OT world, what are we doing? We're the system of record typically for the time series data in your operational environment. We have real-time processing and exception reporting and things on that data. We do calculations inside the server. There's alerting engine, metadata layer, and event tagging. We'll get into some of that as we go here. And then the third piece is, of course, how you present all of this data for users to do something of value with it. And we have our own visualization suite because some of this data, going back to the Pat Kennedy example, that refinery in Hawaii that we deployed, early versions of the technology back in the 80s, can run a trend on their process data going back 30 years. Well, to render a 30-year-long trend and be able to visualize that, you need some specialized visualization tools, and we build those. We also build HMI and authoring screens so you can build screens and visualization. And then we have HTML5 visualization for users on their mobile asset devices, right? And we find that our parts for visualization in HTML5 tend to blend with other people's parts for more enhanced visualization when you start to bring specialized analytics to the table. And then we also know that our visualization by itself isn't the end-all be-all. We, as part of our core strategy, make the Pi system an open system on the high end to enable connectivity and integration with analytics. So let's say you wanted to do predictive analytics or machine learning, or you wanted to do geospatial or business intelligence, those types of analytics. We're not trying to supply those analytics layers. What we're trying to do and are doing is presenting this rich time series and contextual data in a cleansed format, ready to go into that environment, and trying to ease the process of taking this OT data and presenting it into traditional IT worlds. And then if you have custom apps or partner applications or other things, we have a full environment to allow people to come in and interrogate the Pi system directly. So we're building both integrators and allowing users to come into this Pi environment and come get the data out how they want to use it. And that supports and helps us build a very rich, robust ecosphere on how this infrastructure is going to be used. One of the things we've learned, and this goes back to Pat's experience in the 80s, and I hear it all the time today, is that a lot of this quote-unquote big data and analytics, people are spending a lot of time and effort on the process of getting the data together, cleansing it, shaping it, backfilling it, getting the timestamps in order. And there's new job titles coming up out of this. I hear the word data engineer, for example. Not a data scientist, who's the person who's actually running the analytics, but a data engineer whose job it is to get all this data together and put it into a format so that a data scientist who may not be domain expert can use it to run and answer very specific kinds of questions. So, we're responding to that and trying to ease that pain with this idea of these integrators. Again, on the left-hand side, the PI system is that system of record, and on the right-hand side are all these analytics needs and requirements. How do we close the gap between the two? Where does that intersection lie? And that's right in this function where, you know, we need to cleanse this data, because sometimes the sensor data is messy, it's dirty, you got calibrations that go bad, you got all kinds of issues that are out there. You have to augment that data. Again, what do you do if you're missing a bit of data from a place? How do you backfill it and, you know, do those kinds of things? You need to shape this data and get it into a format that the analytics engine wants to consume. Call it 15-minute averages or 10-second samples. How do you want to shape that data and present it up into the analytics package? And then the transmission function. How do you connect the two, right? What does that plumbing look like? So, you know, in summary about OSI, just think about us in sort of two vectors. We support the real-time stuff, right? What a lot of people in operations call small data, meaning what's happening right now in my infrastructure. I want a notification when something's going wrong with my process, and here's a set of calculations around it. That is the small data, what is happening right now. The bigger data is built around this, having a persistence of data across your enterprise at highly granular time series data that you can then present into these environments. So shifting gears, Paul asked me to put together my top 10 list, sort of an homage to David Letterman a little bit here. But after dealing with this environment for 10 years, me personally, and OSIsoft for 30 years, I sort of built this top 10 list of IoT observations, and I wanted to share these as part of my talk today. So number 10, working our way up in Letterman style, the PI system was built and has been built for the heart of data collection and analysis for IoT for 30 plus years. We've got an infrastructure, we handle the connections, we get all this this sensor data and asset data, and we bring it all together. We're expanding the edge of that system as you see these, you know, gateways and routers and other kinds of things, but the function is essentially the same. How you're doing it's a little bit different, but the function is the same. Number 9, this is going to result, and we're already seeing this, in a proliferation of, you know, millions of these sensors out there. They're going to be cheap. There's going to be tremendous cost pressure on those sensors. They're going to have different flavors and variants, but the result is we're going to get orders of magnitude more data. You know, I talked to some of these, you know, I was talking to somebody that runs an airport, for example, and they told us that they thought about 10% of their data actually flows through their building management system. So they're looking at, as we start to, you know, attach to their lights and their air handlers and other kinds of things that aren't attached to their BMS using IoT technologies, we're looking at a 10x explosion on their data from just connecting to what they already have, let alone, you know, the addition of all these additional sensors and things that are out there. And we see this across, you know, whether you're looking at an inside environment, right, that might go into the gateway, an outside environment that might go into some sort of ruggedized, you know, wireless network kind of thing. Whether you're going into a mobile asset, think of a mining truck rumbling down a pit mine and going underground, and think of the dust and the vibration in this highly hostile environment, and think about the technology that needs to support that. Long story short, we just see huge volumes of data. Number 8, that data, the time series data we're learning, has to be contextualized. We have to have the metadata around it as these systems get very large. And that's going to be a key function as we've done a number of these analytics. If you don't have the context around it with the time series data, it becomes very hard for the data science and the analytics community to figure out how to consume these tags and this time series data. And we've got a product for that, AF, and we have customers that use it, and it really helps with, you know, understanding, you know, the asset specific and asset centric view to this data and world and how we present that to users. Point number 7, look, if you're going to run analytics based on sensor data, you better make damn sure that that sensor data is good. And we're finding we've got a partner company called Element Analytics who's taking this time series data from the sensors, they're pushing it into a machine learning environment, and they're doing that to validate the quality of the sensor data. And they're looking for things like, you know, sensor drift and poor calibration and other things happening and dropouts and other things. And they're using those tools to do a validation loop on the sensor data before they send it then on up to the bigger analytics questions, so that the folks running the predictive analytics for, say, condition-based maintenance are pretty darn sure that the quality of the data and that sensor is accurately reporting. Number 6, cheap sensors are not going to be 100% reliable forever. You know, a lot of these sensors, I think, are going to be deployed. Some of them are going to be deployed as fire and forget. They're going to have a one-time use battery in it, and their idea is that it's going to go out. They're going to deploy the sensor. It'll live for a couple years, and then once the battery dies, you know, the next wave of technology will be here, and let's forget about it. Other sensor packages are going to go out there. They're going to be a little more semi-permanent installation, but they're going to suffer from physical damage. In this industrial world, we're going to put sensors onto mining trucks and on pipelines and things like that in very hostile environments. They're going to be subject to vibration and dust and water and caustic materials and emissions and all kinds of different things. They're going to fail. And those failures might be, you know, instantaneous, like on-off, or it might be a slow degradation over time. So we got to recognize that, and we better put process in place to deal with these sensor failures and reliability issues as we scale this out. Number 5, I've touched on this pretty heavily already, but it's this idea of the OT and IT convergence. And typically what you find is these instrumentation and control INC engineers that come from the OT world understand time series data and context and SCADA systems and PI systems and such. And they're going to have to work with the analytics community and the IT community to bridge the two. And we see this IoT being that potential convergence point, and in particular these integrators that we're building, and how do you bring this IoT and the sensor data and you bring that up into your analytics world, your SAP environment. That's right there. And so, you know, that data engineering function is not something at this point to be underestimated. In fact, I think it should be embraced, and you know, we're going to find this convergence at this point. Number 4, standardization will lead to repeatability. What we're finding out there, and you know, I just worked on a use case with a wind turbine, guys that do O&M on wind turbines. They have bearing sensors, temperature sensors out there on the bearings across a whole fleet of wind turbines. Sometimes those bearing temperature sensors fail, or they drift, or they do other things that cause false positives and false alarms and things like that in the control system. So when they go out and replace those sensors, you know, there's a lot of question about standardization on what sensors they're going to deploy, so that they can compare these sensors across the fleet and how they're performing, look for inflection points. And, you know, if they've got a larger number of these things out there, it gives them a lot more to work with in terms of their predictive analytics models. So there's a lot of thought going in by our customers in this industrial space about how to standardize and what that standardization is going to look like at that very low end. I'm really excited about this, and this is going to lead right into Frank's part here pretty soon. Is SAP has built really powerful tools for analysis, right? There's a lot of really great tools out there that are now starting to get applied in process industries, tools that historically haven't been used in a process industry. So I think there's a tremendous opportunity to bring that world together with this ICT world and figure out where they come together. Number two, we believe that this IoT data will also be much more democratic than SCADA data. SCADA has historically been historically locked away in somebody's process control network, and to get at that process control network and pull data out of the SCADA has been sometimes an act of God, or you need a FERC order to be able to go in and get utility data. With IoT, what that is going to introduce is, I can very simply and very inexpensively go put a gateway and some sensors on an asset. I don't have to touch the end user's network. I can take that data and I can bring it up directly to the cloud using a 3G, 4G, LTE connection, or I can get on somebody's mesh network and I can move that data. And that's allowing all kinds of interesting new business models where device manufacturers and OEMs can provide enhanced services. We're also seeing O&M providers being able to get access to some of this rich IoT data to enhance their O&M services without having direct access into people's SCADA networks and things of that nature. We're also seeing this as a way to break down, inter-enterprise data exchanges, right, and creating new value propositions when multiple enterprises get together and start to, bring their data together for analytics across, what were traditional barriers or silos. And my number one observation, yes, I'm a technologist. Yes, I work for OSIsoft. Yes, I go out there and I talk to customers. And if I talk to customers about technology and I talk to them about what the Internet of Things means, and it's worth trillions of dollars and billions of units, in the OT world, and you go in and talk to a chief operating officer, pretty much their eyes are going to glaze over and we lose them quickly. We as a community and as a vendor community need and continue to focus our discussions on the value creation opportunities and the new business models that this types of technology are going to enable. And I think that's the art and the discovery now, is how do we take these IoT technologies and move them towards business value. So with that, I'm going to conclude, and I'd like to turn the podium over to Frank to talk a little bit about the integration of the systems together. Frank, you have control.
Thanks very much, Dave, and also warm welcome from my side. My name is Frank Ruland. I head up the Industry Partner Management Organization for SAP in the energy and natural resources industries. And within the energy and natural resources industries, we are one of the leading dimensions when it comes to the collaboration between OSIsoft and SAP. And also some of the use cases, examples, customer cases that Dave showed in the earlier part of the presentation actually stem from customers in that industry. That being said, we feel that the ongoing and long existing relationship between OSIsoft and SAP is one that is describing actually those value cases and business value propositions that Dave talked about in the last point in any industry, whether it is in energy and resources or in consumer or transportation services. With that being said, some of the customers that we've seen actually using the power of SAP on the one hand side from a system of record for IT or ERP or transactions, more generally speaking, and the power of the PI system on the other hand side for the system of record for OT is a utility company called Alliander in Europe, precisely in the Netherlands, that have used data from the Pi SCADA PLC world to combine that with data coming out of their ERP side for optimizing forecasting models. Because forecasting demand in utility for production purposes based on real-time customer data residing in the SAP billing system, for example, in utilities, is a very interesting scenario. Another customer reference, and for those of you that were at Sapphire earlier this year, you saw the presentation from Centerpoint and the demo there. Centerpoint Energy is also a joint SAP and OSIsoft customer. And what we see here is that with not just the visual analytic capabilities that Dave was describing from an SAP HANA perspective, but also that additional capabilities around predictive scenarios, or the pure mashup of IT and OT data to move really from the insights provided by real-time analytics to the actions or transactions and generating work orders in an enterprise asset management scenario, et cetera, are real value drivers. So what we wanted to do is actually combine the best of both worlds. We understand that both our companies, both SAP and OSIsoft, talk about real time, but we mean two different things from a real time perspective. We definitely, and that's also something that Dave stated, we feel that the whole push towards IT-OT or IoT, Internet of Things, can provide us with the capability to share more data and move into more proactive scenarios, whereas in the past, use cases like the ones at Alliander were built on the manual exchange of data between the OT and the IT teams, if they ever talk to each other. And now we want to move this into a more automated fashion. And that is why for starting for a number of scenarios, we have brought together the SAP HANA and the SAP HANA Cloud Platform together with the OSIsoft infrastructure for seamless data exchange. To bring this into an example and basically make that possible, one of the things that we've done is actually tie that up, tie the Pi system up through a HANA connector with the HANA platform or the HANA solution, so that you can select all the necessary information and not stream everything that is in the 35 years of records from the HANA from the Pi system, but only select those use cases that are important to you to either run, as said, a predictive maintenance scenario, or a work order optimization scenario, or even other scheduling problems. So the picture that you see here, again pointing to more of a utilities example, is where you have your underlying OT systems with all the amounts of historic data and real-time data added every day. And you have the SAP or other IT systems up on top that now, on the basis of a data and computing layer with HANA, can be meshed up and consolidated. Coming slightly before our little demo and use case that we'll present together with Dave, just wanted to show one of those examples of possible business integration, because as said earlier, and as also pointed out by Dave, we now need to make or use the opportunity to really show that with the notion of the Internet of Things, business processes can be reconfigured or amended to create even greater business value by adding data from the OT systems into existing IT processes. One of the examples we have here, or that we found out, is predictive maintenance and services. as an extension of already existing condition monitoring services from an OT perspective, or fault pattern recognition, and with that overall machine health prediction. So that part, the upper part in this picture, is traditionally where the engineering teams and the OT side of the house is very, very active and has the capacity and knowledge to do those fault pattern recognitions and condition monitoring scenarios. But what about actually doing real-time on the basis of machine health predictions, create maintenance or service orders so that you can actually take advantage of information that you collected in real time. And not just that you have the insights that a turbine, transformer, some device or some equipment on your wind turbine is failing. You can actually also schedule the order and make sure that the engineering field services crew that is closest to the equipment, to the wind turbine, for example, is actually receiving the order. And instead of sending that field crew out a number of times, you're just adding it to an already existing or scheduled half-year inspection. And this is, and Dave, with that, back over to you, which we're going to highlight in a quick little demo and in this use case description for the wind turbine scenario. Back over to you, Dave.
Great, thank you, Frank. Quickly, this is a use case. This is built around, this use case and demo is built around the idea of an O&M and service provider and asset management for wind turbines, highly distributed energy resources, and connectivity with bearings and sensors and things of that nature. So I'm going to click through here, and Kayla, could you queue up the video for us, please?
Hi, I'm going to demonstrate the Pi integrator for SAP HANA. So first I'm going to start by creating a new asset view. Using this, I'm going to analyze a wind farm, actually a fleet of wind farms.
I'm not hearing any audio, Kayla.
Hang on one second.
All right, so first I'm going to start off by selecting my Pi server. And then I'll go down to the database that's holding my wind farms. So I'm going to drill in, and first I'm going to select the Big Buffalo wind farm here. And I'm going
maybe,
to select
Dave, while we wait for the audio to get in, what you see actually here on the screen is a view
directly to the volume bar in the lower part.
We can restart it again. It's just the volume thing.
Next, I want to analyze one of the turbines in this shape. So I'm going to drill into the Big Buffalo wind farm. I'll select one wind turbine.
Because of
from here, I'll drag over the active power into my shape.
And we can't pause it.
I also want to get the turbine name.
Sorry.
Well, search for that.
Well, we're going to post the video with the audio for everyone, so you can download it and
all right,
watch it.
So now I have a shape. We can see here we've only got one match so far. What I need to do is I need to generalize
just
my shape.
Very briefly, just a couple of voiceover points
so on the
here
site level, what I'm going to do is I'm going to match on just the template and not
whether
the name.
we paid attention to the voiceover before. But
and then at the turbine level, what I'm going to do is I'm going to use a wildcard in our name.
Connector.
This is going to let me just match all of the
criteria. You can basically, on the basis of the asset framework from OSI Pi, create certain
so we can see now we're getting a lot more matches.
So that you can select a specific type of wind turbine, for example, and with that also select
go over
all
and
the
take a look at a preview of this.
Respective
so here we have a preview of our data
asset types
that we'll be writing to HANA.
The Pi system. So
I'm going to edit the time frame. Right now it's only set for 7 minutes or for 10 minutes.
And based
on
the parameters
to 7 days.
The Pi system, you can now
and I'll change the interval that we're writing over at 1 hour. So we'll write the past 7 days of data at hourly intervals.
The other thing is, because
Frank, just a note from attendees, Frank, they're actually
and our preview is updated.
So I'm hearing all kinds
So
of
now let's
comments,
publish this
and
data.
the attendees are hearing all the audio.
So I'll click on the Publish tab,
That's great.
and I'll choose my
Presenters,
target. In this
shut
case,
up.
it's going to be publishing to SAP HANA. And all I need to do here is click the Publish button. It's running right now, and now it's completed. So let's go take a look at this data now in SAP HANA. Here we have the Wintopia UC table that we just wrote to HANA using CAST. You can see the active power, turbine name, and project name just as we specified them within CAST. We can do a lot of things with the data once we get it into HANA. We're using a decision tree algorithm using HANA's predictive analysis library to predict future power generation. We can see the results of those calculations in this table here. We also can track various events and generate maintenance requests as needed. We can see the results of those maintenance requests here. And finally, we can actually write all of this data back to the PI system. So let's go to CoreSite and take a look at this data as it flows back into the PI system. Here we have a CoreSite display showing the active power versus the predictive power. We're using PI Server 2015 to be able to show the future data here. We can easily switch between different wind turbines. I should also point out at the bottom here too, we're also writing the most recent maintenance notification as we're getting them from SAP HANA. For a wider view of this data, let's take a look at it in SAP Lumira. Here we have the Esri map integrated into SAP Lumira, showing the predicted power versus the active power. Let's take a look at this on a more complete dashboard. So here we're displaying the predicted power versus the active power over all our sites. We can easily add or remove sites and also change the time range. Now, something a data scientist might be a little bit more interested in is looking at some of the more details of our predictions. So we're able to pull up the power curves for all of the actual data that we've been running. You can easily pull up something like this and then find a specific outlier and then narrow down what wind turbines might be faulty. Let's also now pull up another dashboard. Here we have a dashboard giving a maintenance summary for all of our sites. You can scroll over a specific wind farm and you can find out how many overheating events were happening at that wind farm. What this can be used for is in this table below, we have the number of overheating events that are happening at a site. And we also have existing maintenance requests for that site. In this way, you'd be able to add additional maintenance into existing maintenance requests to optimize efficiency. Thank you, and that's a demonstration of the CAST prototype moving data into SAP HANA.
Okay, well, hopefully the audio came across for you. If not, I'm happy to, I'll post this video so it's easy to consume. With that, we are at the end of content, and we have about 5-6 minutes left to do a little Q&A and poll questions. So please respond to the poll questions, and Frank or Paul or I will be happy to take any questions you have for the next few minutes.
Great. Thanks, Dave and Frank. That was very informative. So here's, to start things off, a couple of questions for you. OSIsoft has been dealing with industrial sensor data for years. What's different about IoT, and what does this mean for commercial and industrial users? And Dave, just another side note to that. I actually ran into an old friend of mine at a utility I used to work with back in the 2000s. It was a VP, and you know, at that time, I think you're familiar with that story. I mean, we took sensors from the sensors into, you know, the cloud, even predictive analytics way back then at that point in time. And he asked me, what is this thing called IoT? found it quite interesting. What's your view in terms of why things are different now, even though some people think, haven't we been doing this for years?
From an OSIsoft perspective, historically we've just deployed industrial grade PCs to attach to industrial systems, SCADA, DCS, etc. And those industrial PCs, you might go put one of those in a plant or a location and you'd attach it to a system and get all the data. And you'd have to maintain that industrial PC, keep the windows up to date and patched and all those other kinds of things. If you want to acquire data from thousands of endpoints, whether that's buildings or mobile vehicles or assets and things like that, to go stand up 1,000 industrial PCs and maintain them is a very difficult job. These gateways and routers and technology, this IoT technology, is going to allow us to extend the edge of the Pi system and that data acquisition much closer to the asset, much closer to the edge, and it's going to enable us to do some of these highly distributed data acquisition kinds of concepts. So as we see things like solar panels getting deployed at huge rates in certain communities, how are we going to go get that data? We cannot go stand up a PC for data acquisition. So going in and being able to get that data, get it at a lower level and extending the edge is, I think, the transformation we're seeing today.
Okay, here's another one here. What is the lag between data collection and data availability? And this is a question that came on early in the presentation.
Could you restate that again?
What is the lag between data collection and data availability?
So that's a read-write function, and depending on when you want to get the data, if you want to get the data out of the historian, it's got to get loaded into that environment. So that's sort of on a 1 second type of basis. You can do a lot faster if you get it out of the snapshot and get the data, but it's pretty fast.
I mean, in your case, you guys work with power grids, all that sort of stuff. So basically, that data is made available pretty quickly to those control centers, for example.
Yeah, we're doing stuff also with like phasor measurement, PMU type of data, and that's 60 hertz to 120 hertz kind of data, 60 times a second. We're getting data coming across that environment, and they're using that data for grid stability and advanced control for things like microgrids and decoupled control on frequency and voltage. And we need to be able to present that data to the control logic at blistering fast speeds to be able to do that kind of thing.
Okay. Another question here.
Dave,
how does Pi...
And Paul, maybe to add an example outside the utilities industry, because everybody knows that the time lag there is very rapid. We talked to a chemical customer, joint chemical customer, with approximately 280,000 tags or devices and measurement points, and 10 years of data at 1 minute intervals. So even in the chemical context, which is more batch processing type, you see that there's a very short time lag actually.
Okay, I think we have time just one more question before we wind down. How would an SAP user get engaged with OSIsoft to talk about IoT solutions and use cases?
We have a full team of folks at OSIsoft, from product managers and account managers, that are dedicated to the relationship with SAP and OSIsoft. They can also shoot us an email, and in the distribution of this, we'll put out an email email address, for engagement. You can also contact me, and then for end use customers, the relationship with your OSIsoft account manager can sort of broker all of these discussions.
And Frank, quickly from an SAP perspective?
Likewise, either people can contact directly me, or we have our SAP reps very closely joined at the hip with the OSIsoft team, both from the general account executives as well as Many of those discussions are triggered and brokered by our database and technology sales teams out there in the field.
Great. So we're about out of time. I want to thank everyone for participation on today's call. Reminder, our next webcast is on June 23rd at 12 p.m. Eastern Time. And a somewhat related topic, Accenture is giving webcasts for us focused on the industrial Internet of Things. So I think you'll hear a further extension of some of the things we're talked about today across a number of different capital-intensive industries. Kayla, anything to add to close?
Nope, I think you've pretty much covered it. Just a reminder that today's webcast was recording, and the recording along with the slide deck will be posted to the ASEG discussion forum later on this afternoon. We will also email out those materials to you, and included in that email will also be links to access the recordings from the previous webcasts in this series. So please do consider going back and giving those a listen as well if you've missed any of them. Thank you very much for your participation. Thank you to our speakers for today, and we do look forward to next time. Have a great rest of the afternoon.
Thank you.